Now let us look into the nomenclature shown by the alkenes. As per the IUPAC nomenclature, alkenes exhibit the following names. See, look at this structure: CH3CH double bond CH2. So the number of carbons appear in this formula as 3 carbons and 1 double bond is present. So the 3 carbons, then the word root will come prop, and since double bond is there, propene. And next compound is CH3, CH2, CH double bond and CH2. Since the number of carbons here appear how many? 4, then but, and the double bond start from the first carbon, it is but-1-ene. Similarly, if you look at the third one, CH3CH double bond appear in the second carbon and it is butene. The number of carbons are 4 and the double bond appear at the second carbon is butene. And so if you look at this next fourth compound, number of carbons also same, 4 carbons are present, but double bond is repeated at first carbon and at the third carbon, hence buta 1,3 diene. So we have to stress on the 2 double bonds diene. And if you look at this, so another one is CH2, CH3 and CH3. This compound also having that number of carbons how many? 4, but double bond is 1. And since and main parent chain is consisting of 3 carbons and the branch is 1 carbon, then 2-methyl prop-1-ene. And look at this structure and having that number of carbons 1, 2, 3, 4 and 5 carbons it has, but the structure seems to be branched, and for the first carbon holding the double bond, so hence the name should start from this first carbon 1, 2, 3, 4 and CH3 is the branch. So this branch, if you start the numbering from the double bond, since the chemical properties of the compound depends upon the double bond, hence the numbering will start from that 1, 2, 3, 4, 3-methyl but-1-ene. So as per the IUPAC nomenclature, we follow the rules according to that IUPAC nomenclature. So based on word root, based on that suffix, based on the prefix, so we write the names as per that IUPAC nomenclature. And now let us discuss what type of isomerism shown by the alkenes. So already you know that isomerism is the phenomenon of organic molecules exhibiting different structures for the same molecular formula. That means organic compounds having same molecular formula, different structures is called isomerism. But alkenes, so what type of isomerism shown by the alkenes? So if you observe carefully the isomers of alkenes, the alkenes exhibit structural isomerism and geometrical isomerism. So the structural isomerism, what is the structural isomerism? Means hydrocarbons having same molecular formula, so different called structural isomerism. So if you take one example in alkenes, so propene and ethene. So these have only one structure. These do not exhibit isomerism. But isomerism we can see in molecules, in hydrocarbons having more number of 3 carbon atoms, like butene, but-1-ene. So we can write butene molecular formula in different ways. The butene can be written how many ways? We can write 3 ways. We can write in three ways: but-1-ene, but-2-ene, and 2-methyl-propene. In three ways we can represent, but three different structures will have the same formula, molecular formula. So then this is said to be what we call structural isomerism. We can call this is structural isomerism, we say. So that means the butene can be written in three forms. And if you go further, the butene can be also written five forms also. One is cyclobutane, and other one is structural isomers we can get. Since cyclobutane, means 1-methyl cyclopropane alkanes, three isomers, structural isomers of alkenes. So it can be written means isomers of but-1-ene can be written like cyclobutane, and another one also we can write 1-methyl cyclopropane. But since these structures are saturated hydrocarbons and these are alkenes, these are alkanes. So that's why isomers of alkenes means butene will be three, only three, not five.